This is a completely different type of lava of the one that is above, that is a characteristic AA lava flow. This is a tholeitic, is much more fluid and makes this pahoehoe surface with the typical toes advancing with the lava flow, and has a lot of pressure ridges, and the pressure of the lava underneath burst the crust, the solidified crust, and make this all kind of tumuli and collapses, and but in general it's a very flat surface, the top surface, because being so fluid tends to pound on the depression that make this typical of this. This comes from Montaña de las Nueces, means the mountains of nuts, because when you step on top of these lavas, make like crackling like when you step on
nuts. Very good. Thank you very much, Juan Carlos. This is amazing. So this is the Tholeiite. The Tholeiite was erupted pretty late in the 1730 to 36 eruption. Yes.
Not the last one, but
the last one is just this lava above. But this Tholeiite is very intriguing, isn't it? It's very untypical for Canary eruptions.
I think it's the only example actually of the big lava flow of Tholeiite composition.
And it was extremely runny. It was a low viscosity. That's right.
All the way down to the sea in the Ife.
Wow, so this was traveling really kind of far. Do we know whether it was traveling fast? Do we have any indication of the timing?
Not really.
No, we just know that it traveled far.
No, not very far. I think our lava flows are faster than these pahoehoe type lavas.
Okay, good. Okay, but it wasn't very fast then. So
another interesting aspect is that the famous Cesar Manrique,
the artist,
used lava tubes and lava caves of this same eruption to build a house. He lived
from the Tholeiite.
From the Tholeiite, yes.
Well, it's very decorative. I saw that he had this art piece where he had lava coming through the window, where he took lava chunks and he arranged it so that it looked like it would come through the window.
Yeah, this is typical of the pahoehoe lavas.
So this is he used the Tholeiite pahoehoe for that. Oh wow. I always felt it was a bit kind of, eerie, this image, because then looking at La Palma eruption, I mean, we all know that this is reality, that this can happen. So he made it into an art piece. But I mean, of course, this is something quite serious for people when they're affected.
Another interesting characteristic is that pahoehoe convert into AA lava, but not the opposite.
Yes. It's very hard unless you heat them up, but in nature this doesn't really happen.
Exactly.
So, okay, wonderful. So we'll look a little bit more at these lavas now, and let's see. It's a bit dark down there in the corner, but there we get access to the Tholeiite. There's some good outcrops there. So this is what we're going to study now. Juan Carlos, thank you so much.
Finished. Look here. You can see this is the lichens that are typically. This is the first step of vegetation to colonize recent lavas. It's called Sphenocaulus vesuvianus because it was discovered in Vesuvius.
Oh, I see.
And it's a combination of an algae, you say? Algae,
yeah.
Algae and a lichen.
Oh, I wouldn't know. I'm not good with these things.
And that's why it can live on top of the rock, because the algae gets the food, and the lichen gets the moist. So
I see.
It's a good combination, and finally degrades the rock into soil eventually.
After hundreds and hundreds of years and thousands potentially in this climate here. Wonderful.